Hello, hello, hello. I hope that the mic has started working. Hello, everyone. Hello, everyone. Welcome to the second video of our playlist, which we have dedicated to failures of classical mechanics, the failures that caused us to use quantum mechanics as a new theory. In this video, which I have divided into two portions, in the first portion, we will have some discussion about Newton and Einstein. We will actually see what are Newton's laws and what was the famous assumption on which it is based. And in the second portion, we will discuss about special relativity and we will see how time actually dilates. And in the second portion of this video, I have dedicated this second portion to pion experiment. Pion is actually an experiment which shows that time is not constant, which is this experiment is actually the proof of failure of classical concept of time. So I hope this video makes sense so far. So let us move towards our first portion of this video. I hope this is visible. Let me take a highlighter. Now let us start discussing about the first portion of our today's video, which is Newton versus Einstein. Well, it all started back in 1687 when Newton gave his famous, very famous three laws in his monumental work called Principia. In that book, he gave the very famous three laws of motion, which were based on a very crucial assumption that time is constant. You have to remember this term. Newton's laws were based on one crucial assumption, and that crucial assumption is time is constant. And I hope that you also remember the very famous formula of S is equal to V T. The actual formula that Newton gave us to calculate the distance. Uh, in this formula, the term T is assumed to be constant according to Newton. But everything changed in 1905 when Einstein gave his special theory of relativity. And Einstein said that this is not the case. Time is not constant. Time is no more constant. So through his mathematical calculations, at that time, Newton did not give any proof that time is not constant. But yes, his mathematical calculations were so very correct in special theory of relativity that they actually suggested that time is not constant. I mean, time is different for different observers. Uh, his special theory of relativity was based on two assumptions, and the second assumption was that when something approaches to the speed of light, its time for it slows down. I will repeat it. The second assumption of special theory of relativity is that when something approaches to the speed of light, the time for it slows down. So I hope this makes sense. And this was actually some sort of theoretical explanation that I wanted to give you guys about the history of clashes that shows whether time is constant or relative. And in 1905, Einstein said that time is relative and it is not constant. This was the first portion of this video, which was some discussion about theoretical topics. Okay, let us now move towards our second portion of today's video, which we have dedicated to pion experiment. Pion is a particle just like protons, just like electrons. Pion is also a subatomic particle. Let me tell you something about particle accelerators because that term is relevant here. There are many particle accelerators throughout this whole world. Like one is present in Geneva, which is 27 kilometers, which has a circumference of 27 kilometers, and that is the biggest machine humans have built so far. And in particle accelerators, they take particles and swirl those particles in circles at very high speeds and make those particles collide. When those particles collide at very high speeds, they give out new information, they give out some new particles which we have never seen before. And in one particular experiment, when two protons were collided, uh, they gave out pions. Normally, when two protons collide, they give out particles like photons, electrons, and sometimes they also give out pions. Pion is also a particle, as I said, just like electrons and protons. It is also a subatomic particle. So in one particular experiment, when they collided two protons at very high speeds, it produced pion. And pion is a particle which is made of equal number of quarks and antiquarks. And there are two cases about the pion experiments that we will be discussing here. In the first case, the pions were observed at rest, and in the second case, the pions were observed at very high speed, almost close to the speed of light, 91.3% of the speed of light. In the first case, when the pions came into existence, let me first tell you one thing, that pions are not stable particles. Whenever they are produced, they immediately decay into some other subatomic particles. And in the first case, when pions were observed at rest, I mean they were not moving. When they were produced, they were still, they were at one position, and they showed a lifetime of 26 nanoseconds. When they were produced at rest, they decayed in 26 nanoseconds into some other subatomic particles. So they showed a half-life of 26 nanoseconds. But in the second case, when the pions came into existence and they were moving at a speed of 2.737 multiplied by 10 to raise power 8 meter per second, which is actually 91.3% of the speed of light, they showed a lifetime of 63.7 nanoseconds. So I hope from here you see the difference. And this is the thing we discussed in special theory of relativity. When something moves close to the speed of light, the time for it slows down. When something approaches the speed of light, the time for it slows down. And this is clear from this particular experiment. This is not something joke. This is a real experiment conducted at the laboratories. You see that 26 nanoseconds at rest, and when they were moving at a speed of 63.7 nanoseconds, they showed a half-life of 63.7 nanoseconds. This is something really very crucial, and this changes our whole perspective about the concept of time. I mean, by birth we have a concept about time in our mind, that time is constant. This is not something that Newton told us through his mathematical calculations, but whenever someone is born and he grows up with time, he always assumes or feels that time is constant. This is something already in our instinct. So when Einstein gave special theory of relativity and proved that theoretically time is not constant, this actually shook everything. This was something that challenged our instinct and that challenged our orthodox thinking. What happened? The lifetime of pions increased by 37.7 nanoseconds, which is 145% of 26 nanoseconds. So you see, when something moves as close to the speed of light, at very high speeds, very close to the speed of light, the time for it slows down. And this is very clear from this pion experiment. I hope this is very clear now, that we have discussed about the experiment, that pion, through the pion experiment, that time is no more constant. So this is something really very strange. So at the end of our today's video, I have designed for you guys a question that makes you think a bit about the concept of time. So I have myself designed this question for you guys. So I will not provide the answer for this question, as I need to be honest, I myself don't know the answer of this question. But yes, I have designed this question and I will find out the answer to this question. But you can also take time and think about this question. Let me read this question loud for you guys. The question is, what do you infer from the fact that half-life of pions increased by 145% when they were moving at a speed 91.3% of the speed of light. I mean, what do you get from it? You have observed that and you have seen that the half-life of pions increased by 145%. In the initial, when they were at rest, their half-life was 26 nanoseconds, and when they were moving, they were observed in motion. They showed a half-life of 63.7 nanoseconds. So their half-life increased by 145 nanoseconds, and their speed increased by 91.3%. I mean, initially they were at rest, and in the second case they were moving at a speed of 91.3% of the speed of light. What do you infer from this? I mean, what do you get from it? Well, what I don't know the exact answer to it, but yes, what I am getting from it, the faster something moves, the more slower the times gets for it. So that this is I infer from it. You can also think about it and let me know in the comment section. I have also provided my Gmail account in my YouTube channel, and from there you can contact me at Gmail and let me know about the answer of this question. And in the meantime, I will also uh, try to find the answer to this question. We can also make a separate video on this question. So thank you so much, guys, for giving you a very crucial time. I know that this video went a bit long, but I wanted to clear all of your inquiries about the failure of classical concept of time. So at the end of this video, I'm going to give you a summary. There is a long history that Newton gave his laws of motion, and they were based on the assumption that time is constant. And in 1905, Einstein gave his special theory of relativity, and theoretically at that time he did not give an experimental proof of it, but yes, he showed that time is relative. And in the recent years we have seen through pion, very special pion experiment, that time is relative, time is not constant. And the pion experiment, very special pion experiment, we have seen that when we observe something moving at a very fast speed, moving at a speed very close to the speed of light, the time for it slows down. So thank you very much for thank you very much for giving your very crucial time for watching this video. I will see you in the next video, in which I will be discussing in the same way about the failure of classical concept of space. Have a very good day. Thank you so much.